that's why different animals can eat different plants. Like we eat grapes and avocados, but grapes and avocados will kill cats and dogs. So there obviously are toxins in there. It's just that we have more defenses towards those toxins. But even though we have defenses towards a lot of these toxins, that doesn't mean that that doesn't build up. And chronic exposure to these low-grade toxins can cause harm.
This project is mainly for audio. So, the first question is going to sound a bit strange, it's a bit funny, but it's basically to introduce yourself, just letting the audience know who you are, where you're from, where you're based now, and what you're known for.
Okay. Well, my name is Dr. Anthony Chaffee. I'm a medical doctor originally from California and Washington State. And I am currently living in Australia. And I have a medical practice here in preventative medicine and metabolic health. And I've also been working as a neurosurgical registrar. So sort of retraining in neurosurgery here in Perth as well since 2020. And I have a YouTube channel and a podcast called The Plant-Free MD, where I talk about diet and nutrition, how that affects health and chronic disease, and specifically espousing an animal-based diet approach, similar to what we would have been eating in our infancy as humans. And as long as humans have been humans have been apex predators and top of the food chain, and apex predators are by definition carnivores. And so I argue that that is a very beneficial food, that meat doesn't cause harm, that animal fat does not cause harm, and that in fact it's the new ways of eating that we've introduced in the last century and a half that have largely grown the burden of chronic disease that we're experiencing now. We've always eaten meat, and we're actually eating far more meat in the 1800s than we were in the early and mid 1800s when 1900s then when heart disease became the number one killer in America. So it's not even related. There's not even a correlation between the two things. And it's something we've been eating for forever, as long as humans have been humans. However, there are a lot of new things. The processed food industry has come up in the last 100, 120, 130 years. And that has definitely changed the way we've been eating. And it's also changed our health. And so I try to get that word out there, and so people can go back to a more whole food, natural approach and get back to being healthy again.
So one of the things that's kind of interest to me is practicing doctors who kind of go against convention, because there's a hell of a lot of institutional power in terms of the medical institutions, the pharmaceutical institutions, the food institutions. So, what keeps you going, like on a personal basis? Like, how are you managing to keep yourself mentally together to kind of, push and advocate for, meat-based diets?
Well, just because they work. And it's not that there's just sort of like, oh, well, that's nice. And, some people can feel good eating that way. They've been allowing people to be healthy for the first time in their lives. Some of these people, I can't tell you how many people have come up to me at conferences, said online in comments in my videos that, eating this way has literally saved their life in one way or the other. There have been people that have been so crippled with pain and rheumatoid arthritis that they couldn't get up and walk, and they were just stuck like that for years, and they just were waiting to die and wanting to die, and then going on an animal-based approach like a strict carnivore diet. All of a sudden their pain and inflammation goes away, and the rheumatoid arthritis calms down and goes into remission without medications, and they get their life back. And now they're traveling to conferences just to tell me and others who have, helped them that they've had this dramatic effect. So you can't, once you see that, you can't unsee it. Once you see people reversing these major health issues, I had a patient the other day that had congestive heart failure. He had a 14% ejection fraction, before he went on an animal-based carnivore diet approach. And 3 months later, he had a completely normal ejection fraction, and he was off all of his medications for heart failure. This is someone that was circling the drain closer and closer to requiring a heart transplant to save his life. And that would have given him a number of extra years, but with all the medications to dampen the immune response, immunosuppressors, and the potential rejection of the heart, etc. Once you get a heart transplant, it's not it's just like, oh well, that's just normal now, and you just have a completely normal life after that. You may still die within a few years because of the complications of that procedure and the medications that you're on. And so while it will extend your life, it's not going to give you a normal life. And all of a sudden, he didn't need it at all. And that's pretty amazing. People that are getting worse and worse, diabetic retinopathy, all of a sudden their vision is returning. Chronic kidney disease secondary to diabetes or other issues, all of a sudden that's reversing. The most common cause of renal failure is diabetes, and diabetes has been clinically proven to be reversible in humans, putting them on a high-fat, meat-based ketogenic diet approach. And that's what a carnivore diet is. It's a high-fat, meat-based ketogenic diet using whole foods. And so this is a very normal way of eating. If you think about it, we just put weird names and labels on it, and we think of it as strange, but it's a very normal way to eat. The Maasai eat like this, the Inuit eat like this, the Nanette eat like this, the Native Americans ate like this, especially in the Great Plains where they were just hunting bison, and they would predominantly eat that throughout the year. The Native Australians in most parts of Australia. Australia is a continent, so there's different people in different areas, but in areas that they had an abundance of wild game and animals available to hunt, they would predominantly, if not exclusively, eat meat, except for medicinal purposes, or if they were starving and couldn't get a hunt or something like that. So when you see people eating like this and it completely revolutionizes their health, you can't just say like, oh, well, I'll wait for the study to come out. Like you can't do that. It's not ethical. It's not moral. If I have a patient that comes in with cancer and they say, well, is there anything else I can do besides chemo and radiation? If I don't tell them about the research in humans that's available, showing them the benefits of ketogenic metabolic therapy and teaching them about cancer biology and how the Warburg effect shows that cancer cells need 400 times the amount of glucose as normal cells, and that if you limit glucose, then that can limit the energy supply to cancer cells. That, in my opinion, would be malpractice and immoral and unethical and evil. You have to tell people this. You have to tell them that there's something that could help them. Someone comes in with multiple sclerosis and they're crippled and they can't walk and they're in a wheelchair and they're dying. You just don't tell them that other people have reversed that issue, both symptomatically and on MRI, by going on a red meat and water diet. You can't withhold that information. You have to at least tell them, like, look, this is something that other people have done. And there are different sort of mechanistic reasons why it might work, that your body is reacting to different plant toxins and toxins in food and the different things that we expose ourselves to. And that can create antibodies, and those antibodies can cross-react with our body and our nervous system. And that could be the underlying cause of MS. And so removing those things from your diet can lower the antibodies. We see this in autoimmune issues all the time, such as Hashimoto's, where you can measure the level of antibodies. And when people go on a high-fat, red meat-based carnivore diet, those antibodies do come down, and eventually they go away. And it can take a long time. Especially Hashimoto's, they can get very high, and it can take months or even over a year before they go down to zero. But you check them every 3 months, every 6 months, and they stay strict on their diet, it goes down. Okay. When they eat outside of the diet, they go up. And so it's a very, very clear cause and effect sort of relationship when you look at it like that on a patient basis. So that drives me because it works. And this has been the most rewarding thing that I've ever found in medicine, because, we're able to give people hope for the first time in decades. People that have these horrible issues are now understanding, or at least some of us are understanding, that they aren't diseases per se. This comes from toxic exposure from food we're not supposed to eat. And it's not even food. It's just, it's just things we put in our mouths. Just because you put something in your mouth and chew it doesn't make it food. And so we're doing these things, we're putting these things in our body, and we're getting sick. And you take these things away and we get better. And so, even though, you get a lot of grief from people sometimes, 98, 99% of the interactions I get with people are not only positive, they're stunning. The benefits that people have gotten, the issues that they've treated and reversed, and the medications they've come off of. And you start studying more about the science behind it, the physiology behind it. It's just more and more interesting, actually understanding how the body really works. And so it fascinates me from that point of view. But, just seeing time and time again, just more and more people benefit from this. Like, I just can't not do this.
So you mentioned the toxins from the plants. You are known as the person that's popularized, the phrase, plants are trying to kill you. When I try to explain it to people, I perhaps don't do it in the articulate way that you do. I tend to get more, support for the idea of plants are trying to defend themselves. People kind of can digest that phrasing a little easier. But then also I tend to get even more support when I talk about things like, agrochemicals, pesticides, being sprayed on, vegetation and fruit. And that's why, people can have issues with their health when they eat these foods that they've been told for forever are good for them. But in saying that, I don't know, could you like explain the whole theory behind, plants are trying to kill you, and also the benefit of eating like a meat-based diet to reduce the exposure of toxins, whether they're plant-based toxins or agri-chemical toxins?
Absolutely. So they're along the same line. I mean, people wouldn't understand that we use toxins and poisons in the agricultural industry to stop insects and animals from eating them. We're trying to poison all these bugs. We kill about 1 quadrillion insects per year just in America. And actually that's a big problem, because we're wiping out the base of the food chain. And a lot of animals and other insects and birds and things like that rely on those insects to eat them. And then other animals up the food chain rely on those animals to be eaten as well. So it actually really damages the ecosystem and the food chain, and is quite harmful. But long before that, we need to realize that we don't, spray these chemicals over forests and jungles and woodlands. And why is that? Well, because the plants themselves make their own chemicals of defense. And you're right, it is a defense. It's not that they're actually hunting us down and trying to murder us. That was something that my professor of cancer biology said to me, and actually to us in the class, was that plants have these toxins, and many of them were carcinogenic, and that he didn't eat salads, and he wouldn't eat vegetables, and he wouldn't let his kids eat vegetables. And in his words, he said, plants are trying to kill you. And it was just like, he just hammered that home, that these things are not good to eat. And that just really struck home with me. I wonder if anybody was in that class with me, 20 something years ago, if they ever come across this, that'd be funny. But that certainly stuck out to me. I mean, that blew my mind, and I just stopped eating plants from that day on. When I started looking into it, it did make sense. I mean, I'd already studied botany and biology, and I already knew that that's how plants defended themselves. But it was always plants in the abstract. It wasn't the plants that we eat. Because obviously, well, why would we eat them then? They wouldn't let us do that. They wouldn't be selling this to us if it was a problem. They sell us all sorts of garbage that's bad for us all the time. I mean, there's a thing called the opium trade. That's like people made empires off that. They built empires off the tobacco industry, about the alcohol industry, and the sugar industry as well, and the processed food industry. So this is just the the next opium trade. We just don't really realize it, that we're selling our health for a quick sugar high, and we don't realize it. And when opium was legal and you could buy laudanum and morphine from the drugstore and the chemist, people didn't necessarily realize or think that it was as bad as and dangerous as we do now. And so it's just something that we need to recognize. So plants do defend themselves. Everything has a defense, as you said. And animals can run away or fight back. The 4 major killers in Africa, out of the top 5, they're called the Big 5, 4 of those Big 5 are herbivores. You got rhinos, hippos, Cape buffalo, and elephants. And the other one is a lion. So 4 out of the 5 top killers of humans in Africa are herbivores, right? And that's not because they're trying to hunt, and not because they're trying to kill us to eat us. It's because they're extremely territorial, they're extremely defensive, and if you get near them and they view you as a threat, they will kill you in order to eliminate that threat. So, you could just as easily say elephants are trying to kill you. Not necessarily, but you get out in the wild, and this was told to me when I was in South Africa, was that you need to be very careful with elephants because they live a very long time. They have a very good memory. And one of their family members at some point has probably been killed by a human. And they remember that. And so they're actually quite aggressive towards humans, some of these elephants, these wild elephants. And so they are trying to kill you. Is it that because they have a vendetta against you for, killing their mom 50 years ago? Maybe. Or it could just be because, they view you as a threat. And it's kill or be killed out in the wild. And it is. And it's kill or be killed for plants as well as animals. So everything has a defense all the way down to single-celled organisms. And while animals can run away or fight back, plants can't. They're stationary. And so they have to use other defenses. And they actually go about a very thorough chemical warfare. They make about 1 million different defensive chemicals to try to kill, injure, and disrupt animals and insects trying to eat them. They can disrupt the hormones. So they make a lot of phytoestrogens and phytohormones that can act as those hormones or block the receptors for those hormones. So our naturally occurring hormones don't work. They can make you infertile. In fact, there is a theory that the heart shape, the classic sort of heart shape that you draw, actually comes from ancient Rome. It doesn't look anything like a beating heart, does it? But it's sort of a symbol of love. And you actually find this sort of shape on old Roman coins. And what it was a seed pod that was sort of in that shape and sort of had 2 sort of seeds in it and had this sort of teardrop sort of appearance to it, this double teardrop sort of appearance to it. And that was actually used as birth control. And so that was so people in Rome would eat that. It would make them infertile, and then they could, have sex and, debase themselves, any way they wanted. And in fact, it was so popular and they used it so much that they actually ate it to extinction. They didn't cultivate it properly, and because it was just all over the place. So they didn't think about it or something. But anyway, it's gone now. We don't actually think it has survived. But it was so important. It was on Roman coins, from 2,000 years ago or so. And so, that's a demonstration of the way that plants trying to defend itself, because it's a pretty elegant way of shutting down a threat. We just stop it from being able to reproduce. And now you can't make other little urchins that come around and get taught to eat that plant, right? It's just like, no, we're not doing it. So we're going to cut you off and stop you from reproducing so that you don't thrive and you don't survive and you don't make it. But a lot of them can be directly toxic. There are, the majority of plants in the world will make you extremely sick or even kill you. If you get lost in the woods and you run out of food, you can't just eat any random plant, because most of them will make you very, very sick or even kill you. And of the 400,000 plants in the world, koalas only eat one. Pandas eat one. Cows, horses, and grazing animals, they eat grass, but they eat specific grasses. And if they eat outside of that, they can get very sick. And we have diseases in livestock medicine and veterinary medicine that are very clear: big head, big tongue, limp neck, crazy cow syndrome. All of these things are so-called diseases, but are understood to be from the cows or the sheep or the horses getting into the wrong forage, either being stuck. It doesn't really happen in the wild, but if they're stuck in a pasture and they sort of run out of their normal food and forage, and they don't have enough feed and they haven't been rotated around to another pasture, they might just sort of eat this stuff out of necessity and get very, very sick. And so we understand these things to be from plant toxins. And in fact, big head is from oxalate poisoning in cows, and it sort of remodels the bones in their skull, so like this big lumpy looking head, and that's from oxalate poisoning, stripping out the calcium and remodeling the bone.
Okay.
And so, we have names for these diseases, right? But we know that they're not diseases. And, the leaves that a gorilla eats are different from the leaves that a giraffe eats. Those are different from the leaves that a deer eats, and so on. And you mix those leaves around, they all get sick or die. So even though an herbivore might eat plants its entire life, and herbivores too will opportunistically eat smaller animals, by the by, because it's pure nutrition. It's very easy to turn animal tissue into more animal tissue. It's actually quite difficult to turn plant tissue into animal tissue. You need a special intermediary. You need the microbiome or the microbes in your body to eat the fiber, because no vertebrate animal can break down fiber. They need the microbes to break down the fiber and actually to ferment and break down some of the toxins. And then as a byproduct of that fermentation process, they produce saturated fat, and the bacteria die off, and that gets absorbed as protein. So they eat fibrous plants, but what they absorb is fat and protein. So that's what we need, is fat and protein. We don't need carbs. We make carbs. There's no such thing as an essential carbohydrate. We need fat and protein though. And that is essential. And so, that's what all life is trying to do. So even these herbivorous animals that only eat plants, they have to eat very specific plants. And if they eat outside of that, they can get sick or die. And same goes for us. So there's nothing special that you have to do to eat meat. Any animal can eat meat, but you do have to be specially adapted and designed to break down and detoxify the different poisons in plants. And that's why different animals can eat different plants. Like we eat grapes and avocados, but grapes and avocados will kill cats and dogs. So there obviously are toxins in there. It's just that we have more defenses towards those toxins. But even though we have defenses towards a lot of these toxins, that doesn't mean that doesn't build up. And chronic exposure to these low-grade toxins can cause harm, just like in livestock, it can cause these sorts of issues. It can cause issues in humans, and those same issues can be reproduced in dogs and cats and domesticated pets or pets in captivity if fed the wrong food. When you feed dogs and cats grain and plant-based kibble or feed them the nonsense that we eat, they get so-called human diseases. What the hell is a human disease? It's diabetes, it's obesity, it's liver disease.
Cancer. Yeah.
Cancer, exactly, and autoimmunity. Osteoporosis, that's not something that happens in nature. You've never seen an elephant just crack a hip and fall over on the Serengeti, even though they live 80, 90 years and may die of old age. They don't decompose like we do. Same with elephants in the zoo when they're not being taken down by predators when they slow down too much. They don't get osteoporosis. Cows can get different diseases and different problems when they're intensively grain fed, and get arthritis, and you can get tumors, and you get fatty liver disease. In fact, we force fatty liver disease in the food that we eat and the animals that we eat, like ducks and geese. That's what foie gras is fat liver. And how do we do that? We force feed them grains. Okay.
Wagyu, right?
And Wagyu, yeah. And we're just giving pounds of grains and alcohol, candy. I saw at a restaurant the other day, they had a Wagyu steak that was 3-month chocolate and candy fed Wagyu. And it's like, okay. So a lot of marbling, a lot of fat, but that's sick, right? Isn't it? And so,
Yeah.
and we're surprised that when we eat those same things, the same things happen to us. We're confused somehow of how humans get fatty liver disease. It's just non-alcoholic fatty liver disease. We just don't know what it's caused by. Well, we know what it's caused by in the animals that we keep. And we eat the same things that they eat. And funny enough, we get the same sort of, illnesses. So there are toxins. We have to contend with them. Certain ones are going to be worse than others, but low grade exposure can build up harm. And through technology, humans have eaten different plants, because we've been able to figure out ways of detoxifying things, or not necessarily detoxifying things, but lowering the toxic load and increasing the bioavailability, things like fermentation. So cows ferment things in their foregut, but we figured out how to do that just out in the open. Exposing it to bacteria, actually, that's part of the fermentation process. Cooking can denature some of these toxins like lectins, but not necessarily get rid of all of them. We can do something called nixtamalization, which is how we normally treated corn. And that would open up the bioavailability and allow vitamins and minerals to become more available and get rid of some of the toxins. But that's a chemical process. We're soaking it in lye, putting in ash and clay and cooking and heating and doing all these other sorts of things. There's a lot of processes that went into it to lower the toxic load of these plants. And now we're sort of going away from that. We've understood that for thousands of years, if not longer. And we've only eaten plants out of necessity, and only when we've done certain things to them to lower the toxic, like fermentation. And now people are moving towards, no, we've always been herbivores. We never even eaten meat. We're designed to be herbivores, and we should eat raw food, plant-based, something like that. And that's going right down the wrong path, because these things have toxins, and we're not even trying to detoxify them in the traditional ways we used to. We have red kidney beans. This is a very common food, and as little as 5 red kidney beans have put people in the hospital, as per the WHO, who is no fan of the carnivore diet, I can tell you. But they understand that there are toxins in plants. Cassava is one of the most important calorie sources in the tropics. It's the number 3 calorie source in all the tropics. It's the number 1 calorie source for 750 million people worldwide. And cassava is very high in cyanide. And so there's bitter cassava and sweet cassava. Sweet cassava you can eat. It doesn't have enough cyanide to really kill you in one go, but bitter cassava does. And so you have to prepare it in such a way that it lowers that cyanide load, but it doesn't get rid of all of it. And so the sweet cassava that you're not even trying to get rid of the cyanide, and the bitter cassava that you can't get rid of all the cyanide, this can build up, and you get buildup of low-grade cyanide exposure. This is well known, as per the WHO, to cause thyroid dysfunction, even neurological dysfunction, because it damages and destroys the mitochondria and disrupts the electron transport chain, so that your cells can't make energy, and they can get very damaged and even die. So, there are many, many, many different kinds of toxins. There's a whole class of toxins called goitrogens that just cause thyroid dysfunction and cause goiters. Kale is one of these. And they actually used to give kale to sheep and livestock, but they had to stop because it was killing the young, and they were getting these weird birth defects, stillborn. They would have these massive goiters, so that's an enlarged thyroid because it's not working. And they'd have these thyroids that were sticking out of their neck that was larger than their heads. I've seen pictures of it. And then, so they say, okay, well, we can't do that. So we'll give kale to dairy cows, because they need a lot of feed to make all that milk. And the milk from those dairy cows were giving the people who drank it goiters. And so obviously kale is toxic stuff. And instead of just being like, okay, well, this stuff is not fit for human consumption, it's not fit for anybody to eat, they just said, well, just give it to people, like even though the milk from kale-fed cows gives people thyroid dysfunction and goiters, I'm sure it's fine. We gotta sell it somewhere anyway. So it's pretty wild. But that's a brief rundown on it. But this is in every botany and horticulture book that has ever existed. Any textbook on the subject will verify everything that I'm saying. There's even Cambridge University has a YouTube channel called Cambridge Ideas, and that's an official Cambridge University YouTube channel. And there's their professor of botany and head of their botanical gardens, Dr. John Parker. He did a whole video there called "Don't Eat the Plants," talking about how toxic these things are and how actually you should become, if you want to eat real food that isn't toxic and horrible for you, you should become a carnivore. And this was back in 2011, before that was the carnivore diet was even called that. Yeah, exactly. Yeah. So this is a real thing that people know about if they look into it.
So with regard to the plant, so do you subscribe to the idea that with regard to the agri-chemicals, the pesticides and everything that's sprayed on grass and feed effectively, do you subscribe to the idea that it's better to eat red meat because there is almost like a filtration process? They have multiple stomachs that enable them to make the feed that they eat a little less toxic to the humans that then eat their meat.
Yeah, well, I mean, that's exactly right. And it's certainly better to filter it through the animals than to just eat it straight ourselves, because you're adding insult to injury there. You've got plants that are already toxic, and they were making them more toxic by putting all these chemicals on them, so even less animals can eat them so that they can get a better crop yield. The ruminant animals do seem to be able to break down a lot of these agrochemicals, and even the chemicals in plants that they're not really designed to eat, that aren't really healthy for them. At least they do go through that fermentation process, and it lowers the toxic load, and so they're bringing in less toxins. I did see an article suggesting that cows and other ruminants could actually break down glyphosate, for example, in their rumen, and through that fermentation process, and so they wouldn't absorb it. Whereas things like the monogastrics, like pigs and chicken, if they were fed these glyphosate sort of products and crops, that they're just going to absorb that, and so there's going to be glyphosate in the meat as well. I'm sure some of it will be filtered out, but it's going to be much better with the ruminant animals. And so while it is better to eat ruminant animals for that reason, even if they're grain finished, than pigs or chicken or fish that are farmed and raised with the wrong sort of food. I mean, if you farm something and you feed it the right food, fine. But if it's being intensively fed food that it's not designed to eat, it's not going to be as healthy as it should be either. So I'm perfectly fine with people eating grain finished. It's still exquisitely healthy. I think of it as sort of like the gold and silver medalists in the Olympics. And, silver lost to gold, and that's sad. But silver also beat everybody else on earth. And so it's actually a pretty good spot to be in. And that's what I think of as grain finished. They objectively have less micronutrients, and the macronutrients are slightly different. For instance, they'll have more BCAAs in grain finished, and they'll have less DHA and EPA in the fat. Those are the animal fats that we need for our brain. 20% of our brain is made out of DHA, for instance, and you really have to get that from your food supply. We don't really make it very well ourselves, and you can't get it from plants. It has to come from meat. And so you have a better constellation of macro and micronutrients in grass-fed and finished. However, grain finished is still better than pretty much anything else you're going to eat. And it does do a pretty good job at filtering these things out. And that's why most people find that they do best with ruminant meat, even if it's grain finished.
Okay. You touched on the brain health. So kind of as you know, my mum, she had Alzheimer's. She had a stroke that kind of accelerated the Alzheimer's. And she recently passed away from another stroke.
I'm so sorry.
Thank you. And for me, the reason why I got into meat based was her health. I kind of looked at her life and I was like, she followed the medical guidelines. She followed the nutritional guidelines. There were some places where she strayed. For example, she had a bit of a sweet tooth, but I wouldn't say it was a sweet tooth that by conventional standards was, kind of crazy. But it was a sweet tooth that she had. She had a lot of stress in her life. I know that stress kind of, you know, um, impacts, cognitive health and, can have a part to play in Alzheimer's. Um, but I kind of, in the stuff that I was looking at, the stuff that I've read, the videos like yours that I've come across, it made me think about, the whole idea that she wasn't eating enough red meat that would have given her that brain protection. And then on the other side, I had a good friend of mine. His mum she was part of the low fat, aerobic, generation, of the 80s and 90s. And she's the kind of person that, by conventional standards, you look at her and you'd say, her history with her history of, being somebody that was health conscious. She shouldn't have got Alzheimer's either. So then it brought me to this idea of eating red meat being protective of the brain. And with your experience, with your knowledge, with your, kind of neurosurgical background, could you explain to people why red meat is protective for the brain, for, diseases like Alzheimer's and dementia and strokes?
Well, it's part to do with the qualities of red meat. It's also part to do with excluding other things as well that can actually cause harm. And so it takes both of those things, and also just getting away from the myths about what red meat does, which is they say, well, it raises your cholesterol, and actually may or may not do that. If you eat carbohydrates, it's sort of a moot point. If you stop eating altogether, you just stop eating for 5 days, your HDL will go up, your triglycerides will go down, but your LDL will go up as well, because that's what your body wants to do, because now you're running on fat. And your body needs to transport fat, and LDL and HDL transport fat around the body. They're supposed to do that. Your brain is made out of fat. 60 to 70% of your brain is fat. A lot of your brain is made out of cholesterol. 20% of your brain is DHA, as I mentioned. So these are very important. And so when you're eating fat and you're running on fat, and you have higher cholesterol, your body works better, your brain works better. So higher LDL cholesterol is actually associated with lower rates of Alzheimer's, dementia, and Parkinson's, for instance, and even neurodevelopmental delays such as autism. Mothers that have higher levels of LDL cholesterol during pregnancy have lower rates of kids with autism, and the ones that eat more saturated fat during pregnancy also have lower rates of kids with autism as well. So, there's so many valuable nutrients in red meat that are essential for your brain, such as choline, such as cholesterol, such as DHA, such as EPA, but also carnitine. People forget about carnitine because it's thought to be a non-essential amino acid, but it's only conditionally non-essential, because sometimes you need more than others, but also only 70% of people make a sufficient amount of carnitine. Carnitine is vital for the energy transport down to the mitochondria, so you can have normal, proper mitochondrial function. And if you don't get energy to your mitochondria and your cells, you can't produce energy properly, they don't work properly, and your brain doesn't work properly, it doesn't develop properly, and actually starts slowing down and going south. So, and this can cause a misdevelopment in the brain. Texas A&M University actually showed a sort of a causal link between at least one form of autism, which is in these children that don't make enough carnitine and have been raised in a more plant-based environment without meat. Meat is the only place you can get carnitine from if you don't make it yourself. And so if there are these 30% of people, because again, only 70% of people make enough, that means 30%, nearly 1/3 of the planet does not make enough, or maybe doesn't even make any at all. And so that's a huge number of people. And if you are one of these kids and you're trying to develop your brain and you don't have enough carnitine, you will develop this form of autism, which is, a developmental delay. It's your brain not developing to its genetic design. And that's tragic, because that didn't have to happen. That should have developed in a much different way, but it was held back by that. Well, the same is true for the adult brain. If you're not getting the right nutrients, if you're not getting enough carnitine, if you're not getting enough cholesterol or DHA or all these other sorts of things, choline, then your brain can't maintain itself. Every minute that you're awake, you get low-grade brain damage, because when your neurons are firing, they actually damage themselves. And the neurotransmitters, the metabolites of the neurotransmitters actually damage the neurons themselves as well, which is kind of a crazy design, but that's how it is. And so they have to be able to recycle these things. They have to be able to repair and heal that damage. If you average less than 6 hours of sleep a night, you are 6 times more likely to develop Alzheimer's, because when you're sleeping, that's when your brain is repairing. And if you're getting enough sleep and your brain is repairing, but you don't have the materials to rebuild your brain, you're not going to be able to do much work. So you have all these amazing building blocks and materials and nutrients that are vital for your brain health. Some are essential, meaning that you cannot get them anywhere except your diet, and some of them are only found in meat, such as carnitine. Choline is largely found there as well, and this is vitally important for your brain. DHA, EPA. Again, these are very important. Cholesterol is very important. There are so many papers in the peer-reviewed literature detailing how disastrous it is when you disrupt the normal metabolism, the cholesterol metabolism of the brain. You get very serious neurological issues. And yet we have been working day and night for the last 50 years to disrupt our body and our brain's cholesterol metabolism, because we think it's going to cause heart attacks and strokes. No, it's just going to make our brains work. It's going to make our bodies work. All of our hormones are made out of cholesterol. Our brain is made out of cholesterol. Every single cell in the body, the cell membrane, is cholesterol. Bile is made out of cholesterol. It is such a vital and important molecule, and we've just vilified it just unfairly. It's ridiculous. The other side of it is what you're not taking in if you're only eating red meat. Now, if you're eating red meat, you're going to get a lot of those nutrients, and that's going to really help the body and the brain. But there are other things that simply cause harm, like we sort of touched on with all the plant toxins. Some of those things are neurotoxic. They can damage the brain directly. Linoleic acid can be very inflammatory and damage the brain. That's the omega-6 fatty acids found in plants. And that's, a quick aside. People say we need omega-3s and we need omega-6s. No, we need specific omega-3s and we need specific omega-6s. We need the animal versions of those. We need DHA and EPA. Those are the omega-3s that we need. We don't need ALA for our brain. That's alpha linoleic acid. That's what's found in plants. That doesn't do the job in our brain. We need DHA and EPA. We don't need linoleic acid, which is the omega-6 in plants. We need arachidonic acid that is found in meat. Now, you can make arachidonic acid from linoleic acid, but linoleic acid also goes down other pathways and causes, different problems. It doesn't just turn into arachidonic acid. So there are certain things that damage the body and the brain. One of them are carbohydrates. Alzheimer's disease is now being called type 3 diabetes because we see insulin resistance, profound insulin resistance of the brain in Alzheimer's patients. We see this very clearly on PET CTs, where we normally look for cancer cells by injecting people with radio-labeled glucose and then putting them in the scanner to see where that goes, and we see what lights up. And typically the brain would light up because the brain has a high metabolic demand and can take in a lot of glucose. And so we see decreased glucose uptake in Alzheimer's patients. And so if you get insulin resistance and you're not able to get enough energy into the brain's not going to be able to function properly. It's not going to be able to rebuild and repair itself. It's going to start to atrophy. It's also going to atrophy when you're taking away all these vital nutrients that it has to have, that you really only get from meat, And then the lack of energy supply means that the brain that you've now damaged and atrophied now doesn't even have enough energy to run to its capabilities. So when you get rid of carbohydrates and your insulin goes down to a normal level, you start producing ketones. You start being able to run on your fat stores. And then, yes, LDL and HDL are going to have to transport that around your body. So your HDL and LDL can go up. They don't always. HDL tends to go up. LDL sometimes goes up. Typically in thinner, healthier, more metabolically fit people, LDL goes up. So, we look at that healthier phenotype and we're seeing the higher LDL and we're seeing lower LDL and the more obese, metabolically sick phenotype. And for some reason we're saying, ooh, high LDL bad. No, it's associated with better health. So why are we still blaming this? There's never been any shred of experimental evidence to show that cholesterol caused heart disease ever. In fact, there have been 5 that have shown the opposite, shown that it's actually either protective or that cholesterol and saturated fat are actually beneficial, or at least it's not a benefit to reduce saturated fat and cholesterol. But when you get rid of carbohydrates and sugar and your insulin comes down, you go into ketosis. Now you're mobilizing fat to your liver, and your liver's making blood sugar, glycogen, and ketones, very importantly, because ketones don't require insulin to be used in the cells. And so all of a sudden you bypass this insulin resistance in the brain, or just never build it up in the first place if you're always running on it. And so now your brain is running on ketones. And you can see people with Alzheimer's or other forms of dementia really perk up quite quickly within a few days once their ketone levels start going up and their brain starts running on a more appropriate energy source. People don't realize this. They think that the brain has to have glucose. Well, there's parts of it that do need glucose, and good news, you make glucose and you'll have exactly perfect blood sugar levels all the time if you don't eat carbohydrates. It's when you eat carbohydrates, you get too much and too low and too much and too low. But when you don't eat any of them, it's just perfect the whole time, as long as you don't have diabetes and on medications and things like that under normal circumstances. And so when you have ketones available, your brain runs on those ketones, even if there's sufficient amount of glucose available. If you have enough ketones, your brain will only run on those ketones. So cortex, neocortex, 2/3 of the brain will only run on ketones. It's only when the ketones start going down that you'll start filling in those gaps with glucose. Otherwise, they won't run on glucose at all. There are certain parts of your brain that will still run on glucose, but the rest of it, including the part that we have, our thought and memory and things like that runs on ketones. And so it's very important to be in the right metabolic state and have the right energy for your brain as well, and to get these toxins out of the way so that they can stop poisoning the brain. They can stop disrupting the normal cholesterol metabolism of the brain. You can remove these neurotoxins and inflammatory toxins that can cause inflammation and problems in your brain. You're getting all these amazing nutrients from red meat, and including creatine. Your brain is very energy dependent and actually requires a lot of creatine, a lot more creatine than the rest of the body. And you'll get 5+ grams of creatine in red meat if that's all you're eating for the day, or more, depending on how much you eat. And then you're also going to be running on the proper energy source, which is ketones, and you'll bypass the insulin demand and potential insulin resistance, and people's brains just work better. And that goes for adults, and that certainly goes for children. We've seen since the agricultural revolution that the average brain size is actually for adult men has dropped 11% and has dropped 17% in women. And that didn't take thousands of years or hundreds of years even. That happened overnight. That was immediately when we moved to agriculture, the brain size dropped, and that has to do with development. We're not giving our brain what it needs, and we're hurting it. And so we are not developing to our genetic potential, and our brains aren't as big. and our kids aren't as healthy, and we aren't as tall, and our teeth are all crooked and crowded, and our jaws don't form all the way, and we don't get our wisdom teeth. And everyone's, oh yeah, you just take your wisdom teeth out. You just take your wisdom teeth out. Well, why is it that no one ever used to have to take their wisdom teeth out except in isolated circumstances? And why is it that pre-agricultural fossils have perfect jaws with perfect teeth, no crooked teeth, no unerupted wisdom teeth, and then immediately after agriculture, you start seeing smaller jaws, smaller hard palates, and crooked teeth, and big, crowded, horrible looking mouths? It's not a coincidence, and it's not genetic. It's nutritional. I mean, when have you ever seen crooked teeth in a wild animal? Like watch Discovery Channel. They have just perfect teeth all the time. They don't have dentists. They don't have orthodontists. That's a pretty new profession, actually. And it wasn't that just, people just had to, people did have to suffer with this previously, but there wasn't as much of a demand for it. And Weston A. Price showed that this was nutritional. And we saw and see this in, dentistry journals now, talking about how crooked teeth and smaller jaws are actually nutritional. It's not genetic. So a lot of these amazing, important nutrients are there, and we're getting rid of all this other stuff that causes harm. So that's a sort of a thorough look at the benefits of eating meat for the brain.
And for some, let's say somebody's kind of watching this who maybe one of their loved ones has been diagnosed with Alzheimer's, yet they're seeing messaging and potentially seeing examples of people who are seemingly thriving or seemingly healthy on a plant-based diet. And they're advocating, for people to go on a plant-based diet to help with their cognition and their brain health and their physical health. Like, what would you say to those people in terms of why potentially these people could seemingly be thriving on a plant-based diet?
Well, the thing is that you always have to ask the question, compared to what? And so that's a very common question asked in economics is like, oh, well, GDP is okay compared to what? Compared to what? Compared to what? It's always compared to what? And so the issue is that if you're eating, a processed food diet, which is a plant food diet, and you get rid of that processed food, you go to a more whole food approach, and you just happen to throw out meat and you throw the baby out with the bathwater, well, you'll get improvements because you've gotten rid of some of the things that are more toxic for the brain, and so you can improve in that way. But you won't get any of those important nutrients from the meat, and so maybe you get less toxins, and you can even do a ketogenic plant-based approach if you really wanted to. It's a struggle. It's not easy, but you could do it. And that can improve as well. You get ketones up into the brain, and the brain has better energy source. It is something specifically for Alzheimer's, is that plant-based diets have not been shown in clinical trials to be a very good method of treating Alzheimer's, but high-fat, meat-based ketogenic diets have been shown in clinical trials in humans to be a better treatment for Alzheimer's than every medication ever trialed. And so, this is important. And the meat part of that is important too, because that's where your brain gets the nutrients. And so while you can reduce the toxic load from eating, processed foods and processed plant foods, and eating more whole foods, and especially if you're, cooking them and preparing them and fermenting them in ways that reduces the toxic load and improves the bioavailability of the nutrients, that can definitely have a net benefit. But does that mean that it is the best that you can possibly do? I would argue that no, it's not. And people make that same argument about carnivore diets. And they say like, well, this is just people going away from processed food diets. That's the only reason they're getting better. No, because people are on whole food plant-based diets and destroying their health. and then they stop eating all plants and they only eat meat, and their health dramatically improves. Or they're eating a whole food omnivorous diet where they're eating meat and they're eating fruits and vegetables and they're eating grains and all that sort of stuff. And then they cut those out and they just eat meat and their life it changes. Or a whole food ketogenic diet and they just drop the vegetables and their health improves dramatically. So, it's not just because people are just going away from processed food, but when you're looking at a vegetarian diet, it largely is. And, and there's a lot of people that go plant-based and put on a lot of weight and get autoimmune issues and horrible health. I pick up the pieces, on these stories all the time. Probably 60, 70% of the people who follow me on, YouTube and Instagram, that are doing a carnivore diet were plant-based at one point, because the same motivations are there as I have, as you have, as probably everyone listening has, which is to try to be as healthy as possible and try to do the best thing for yourself and your family and even the planet. But we have been sold a false bill of goods that the way to do that is with plant-based. It's not. And so all of these people have had these very good motivations, have tried very hard to do the right thing, and have destroyed their health, destroyed their family's health, and found that it actually destroys the environment too. And then they go, okay, well, maybe I need to try this other thing. The motivations are still there. They're just trying to find what works. And then they try just a carnivore diet, and they look at that, lo and behold, it works a lot better. So it's typically because it's compared to what? They go plant-based, and I ask them too all the time. People say it's like, well, no, I went vegan and everything got better. And so I was like, yeah, but it wasn't because you dropped the meat. And they were like, no. As soon as I stopped eating meat, everything got better. And I said, okay, so you still drinking alcohol, still smoking cigarettes, drinking soda, eating cake and candy and cookies and all these sorts of things. Oh, no. I never eat out. I don't go to restaurants. I cook every meal. I don't have any sugary drinks. I stopped drinking alcohol. I don't smoke. And it's like, okay, so you've just changed about 50 different things that had nothing to do with meat. And yet you're saying that when you dropped the meat, things got better. Well, I bet that it did, but that's called a coincidence. You did 50 other things at the same time. And so you can't say that that's just from the meat unless you did everything else exactly the same and then just stopped eating meat. If you just ate all the junk food and Oreo cookies and garbage and alcohol and cigarettes and all that sort of stuff, and you just stop having a steak with that, then we can talk. But that's not the case. That's not what these people are doing. It's called healthy user bias as well. When you start doing things and making changes in a healthy, with what you feel are healthy, you're likely to do other things that you feel are healthy as well. You're likely to start, drinking less, staying out late less, getting proper sleep, exercising, developing healthier family and social relationships, things like that. There are a lot of things that can come into play. And you have to be mindful of that. And so, there's a lot of, papers and articles saying that, is it that eating fruits and vegetables makes you healthy, or is it just that healthy people eat fruits and vegetables because they're told it's healthy? It's much more likely to be the latter.
Okay. Is there any situations where, particularly I'm looking at it in the kind of athletic or sports realm, is there any benefit of somebody including carbohydrates in their diet for sporting performance, for athletic performance?
Including or excluding?
Including.
No, not really. I don't think there is. When you eat carbohydrates, now, that with the caveat that, being properly fat adapted, being properly keto adapted, if you haven't properly keto adapted and fat adapted, then it may be that you still need to have some carbs. If you're in the middle of the season, maybe you can't, change right in the middle of the season. I did. I felt great. I didn't have a real lag. I have no other people that have been, professional athletes and people that, that were, just missed going to the Olympics for the decathlon. My friend Ryan Talbot, who he was a 3-time NCAA Division I All-American decathlete after he went carnivore, and he's actually switched he switched mid-season. He said he sort of, had a bit of a weird 2 weeks, but then after that, but it didn't affect his performance all that much. It didn't drop his performance. And then after that, his performance took off. But then other people find that it takes, several weeks or even a couple months before they start getting the proper energy levels. So if you're in that transition phase and you're doing this sort of during the season, it may be that you just have to wait till after season. But, if we're talking about people that are fully keto adapted, and, is it advantageous to add carbs? Sometimes I don't think so, because the thing is you are making all the glucose and glycogen and now ketones that you need. And, people say that, well, no, you can't be a high performance athlete because after about 60% VO2 max, once you start getting up into, harder levels of exertion and you're breathing harder and you're having a higher oxygen demand, that your body has to burn carbs. It only burns carbs at higher VO2 max. And that's only true of people eating carbs, because now we have studies in humans, in elite level ultra marathoners and others who have shown that having been at least keto adapted for 9 months, on average 20 months for this study, that they found that they were getting the majority of their energy from fat oxidation at VO2 maxes of 90% or more. And so they really weren't running on carbs. The vast majority of the energy they were producing came from fat metabolism, not carbohydrate metabolism, as long as they were keto adapted. So that sort of blows that myth out of the water. That you have to have carbs for the higher levels. This is what they talk about, like zone 2, you want to keep your heart rate around here. You want to keep your VO2 max around. That's the fat burning rate. Only if you're eating carbs. If you're on a ketogenic diet, you're always burning fat. You're never not burning fat, and you're using some carbs, but you're predominantly using fat. In that same trial, they took these ultramarathoners and they had them do big competitions. So they had a 100-mile run, and they had a short burst, maximal effort sort of sprint, and they had another high performance maximal effort exercise as well. And they found that the keto adapted athletes actually outperformed the carb athletes, and these were all elite level athletes. And they took muscle biopsies of all the athletes before, directly after, and 3 hours after these rigorous exercises. And they found that the keto adapted athletes had the exact same muscle glycogen levels, even slightly more directly after the exercise. And then 3 hours after, the carb athletes were sucking down gels and sugar water and Gatorades and things like that. And the keto athletes didn't take anything, and their bodies just didn't take any carbs and completely regenerated the exact same amount of glycogen. So the body does this all on its own. So you don't need this to make glucose. You make all the glucose and glycogen you need, but now you have ketones and you're running on fat, and you're running on fat oxidation, and they're outperforming the carb athletes, even if it's slightly. They're still outperforming them. And the most important thing is that when you're in a ketogenic state, you have access to your fat stores. You're running on your fat. You're not running on your glycogen stores. You're running on your fat stores. And you're replenishing your glycogen stores as you go. And so glycogen is not a great storage. That's not our main energy storage. It's not. Fat is. Of course it is. It's way more energy stored in our fat than in our glycogen. In a 65 kilo individual, you will have about 2,300 kilocalories of energy stored in the liver and the muscles. And okay, well, that's a decent amount of calories, but you will run out, especially if you're doing a real high intensity sort of exercise, or a marathon or a triathlon or an Ironman or something like that. And a rugby game, when you're just at a dead sprint, nailing people all the time, you just use a lot of energy. And then but then that same 65 kilo individual at only 6% body fat, so extremely lean, elite athlete level body fat percentage, just that 6% body fat on a 65 kilo person is upwards of 35,000 kilocalories of energy in that fat. And so you have 15 times the amount of energy stored in 6% body fat as you do in the glycogen of that individual. And, let's be realistic, not many of us are at 6% body fat. And so we probably have even more energy available. So there's a huge advantage. You get, I would argue that when people are more and more keto adapted, that they'll likely have better and better performance advantages. They'll be able to recover better. They won't have as much inflammation, so they'll be able to train harder, train longer, and recover faster. And so they can get in more training as well. So they're going to have, exponential growth. But also you are, you're generating all the glucose and glycogen that you need. And now you're running on fat as well. And now you have access to fat. So it's a huge advantage just having that access to fat. Mm-hmm. And as Professor Tim Noakes found, looking at these different athletes, and the carb-fueled athletes versus keto athletes, the carb-fueled athletes were not outperforming the keto athletes at the very least. At best, you could say that they were evenly matched. And in some studies, keto outperformed them if they were fully keto adapted. And then there are other studies that show that the people, when they weren't keto adapted, they weren't performing to the same level. But we understand that there is an adaptation period. But in ones that are fully keto adapted, it only takes a few weeks to do that. Well, not fully, but to the point of being able to compete. Then you're going to be able to compete at least the same level. And Professor Noakes showed that. He actually did a crossover trial with, not elite athletes, but, just recreational athletes. And they took these individuals, and one was a keto group and one was a carb group, and they let them keto adapt for 6 weeks. So it was 42 days. And that, and they said that by 3 weeks, it was, everyone was pretty much keto adapted, but they gave it a long time just to make sure. And they did all these different tests, and they all performed at a certain level. Then they crossed them over, and the keto athletes became the carb athletes and vice versa. Gave them another washout period, and then they gave them another 42 days to get adapted again. And again, there's no drop in performance. So, the least you can say is that you won't reduce your performance by being on a ketogenic diet. And you'll have the benefit of having access to your fat stores, so you won't bonk, you won't, hit the wall and run out of energy. You can just keep going. And as you get more keto adapted, we're seeing in other trials that people are actually outperforming the carb athletes as well. The really interesting part was that in the carb athlete groups, in a lot of these things, while they were performing, to, the same level as the keto athletes, you look at their blood markers, and all these guys, because of the amount of carbohydrates and sugar gels and things that they were taking down for these, competitions and, ultra marathons, all that sort of stuff, they were pre-diabetic. They were literally destroying themselves. And so when you talk about athletics, you really don't want, that's talking about, you're giving yourself, metabolic syndrome and diabetes and things like that. You have now completely shortened your career. You're not going to be recovering as well. You're going to be getting sick. You're not going to be able to recover. You're going to get arthritis. That has to do with glycation and damage to the articular cartilage and to the spinal discs and things like that as well. Studies have shown that there's a buildup of glycation end products, these advanced glycation end products. That comes from high blood sugar. Diabetes comes from high blood sugar. A lot of diseases come from high blood sugar. So stop eating sugar, and your blood sugar goes down to normal, and you can either perform to the same level or higher and still have access to your fat stores, and you don't get sick. So no, I don't think there's any advantage to eating carbohydrates. I think there's huge disadvantages to doing it.
So you've spoken in terms of performance and health. Another angle that sometimes people focus on, a lot of people focus on, is the aesthetic. If your goal is an aesthetic goal in the sense of trying to pack on as much muscle as possible, does your position then change in that carbohydrates help to pack on excess muscle that you don't actually need?
No, you don't pack on extra muscle when you eat carbohydrates. Our muscles aren't made out of carbohydrates. They're made out of, protein, fat, cholesterol, those sorts of things, collagen. not carbohydrates. And if you need carbohydrates, the carbohydrates you need, you make.
But in terms of retaining, there's an aesthetic kind of muscular look, which is, I don't know, potentially retaining water, or it's a glycogen thing.
Yeah. Well, you can do that. And, so I have heard of, if you're doing like a fitness competition or something like that, one thing they'll do is they'll just shred down and get horribly dehydrated and do all these other sorts of things. And then the night before, they'll just eat a whole bunch of carbs and pizza, and the glycogen and water weight will just plump up those muscles. That's certainly something that gets passed around in the bodybuilding circles. But if you're talking about actually building real muscle, then no. The thing is that when you're eating carbohydrates, again, this is what we do to cows to fatten them up and to put fat in the muscle. That's called marbling. And human marbling is called myosteatosis. And so if you're eating a whole bunch of carbs, you will bulk up. But it depends on if you want to bulk up with lean muscle or do you want to bulk up with fat and muscle. If you just want the muscle, then skip the carbs. You'll look bigger, if you're eating the carbs. You'll put on fat, you'll put on water weight, and you'll put on intramuscular fat in the muscles. So those muscle bodies look bigger. But if you looked at them on an MRI, you'd see they were infiltrated with fat. And so that's why they look bigger, but they're not actually muscles, and they're not as strong. They're not as healthy. You're not as healthy. And so this is when people are bulking up and you say, well, you can't put on muscle unless you put on fat. And then you try to cut down and you lose muscle, if you're losing fat too. Well, only if you're doing it wrong. If you're doing that with carbohydrates, well, then you're putting on a lot of fat and in the muscles. And then you start, going ketogenic. Oftentimes they'll just eat a bunch of lean protein and starve themselves. And then they'll lose a lot of weight, and they think they're losing muscles, and the size of muscles look like it's shrinking, but that's because the water weight and glycogen and the fat is leaving those muscles now. Mm-hmm. So it was never muscles in the first place. It was fool's gold. And so the old school bodybuilders, even up until Arnold Schwarzenegger's day, they were just steak and eggs, and they were largely ketogenic. Vince Carano was called the Iron Guru, and it was just steak and eggs. And he said that the thought of our understanding of biochemistry of the time was that you need some glycogen in your liver, and so once a week you eat some carbs to carb load up your liver, because they said, well, you want this for your workouts, but and the only way to replenish glycogen in your liver is to eat carbohydrates. That was just their understanding at the time. That's wrong. You don't need carbohydrates. We've even seen this in wolves. We did liver biopsies and muscle biopsies in wolves, and they don't carb load before they chase caribou for 10 hours. So they're like, do they even have blood sugar? Do they even have glycogen? I found out, yes, they do. And it's rock solid. And so you find that you'll have the same amount of liver glycogen. Well, you can have more liver glycogen when someone is carb loading. And so someone who's not carb loaded on ketogenic sort of diet will have 1/3 the glycogen levels of someone who is carb loading. But while those carbohydrates and those glycogen is going down, and the carb athlete, the ketogenic athlete, stays still because you're constantly replenishing the glycogen that you're using, and so it just stays still. So you have an unlimited amount of glycogen. And so, in Vince Caranda's day, they thought that you had to eat carbs to pack in your liver glycogen, but you'd only do it one day a week. And so it was one day a week, and then all the other days was steak and eggs. And then was getting ready for fitness competition. There was no carbs, it was just steak and eggs. And this guy came in and absolutely just blew everybody away in these fitness competitions. Then he started training people in that manner, and just started getting some of the best physiques. This was the golden era of bodybuilding. This is when people had the most amazing physiques in history. And now he's got these mass monsters. They're just taking just obscene amounts of juice, and they're getting like bloated bellies with HGH gut, where they're getting all this enlarged organs and things like that. And it's just it's not, you're supposed to have a slim waist, sort of that V shape,
V-tape
aesthetic, and so they had that. And Vince Guarana, the dude was in his, 50s, 60s, still just shredded. And that's what he ate. Serge Nubret was actually Arnold Schwarzenegger's body idol. And he was this big French dude. He was just jacked. And he ate 6 pounds of horse meat a day, and so, and that's what Arnold did, when Arnold, in Pumping Iron, that movie that he did when he was doing his, Mr. Olympia, during his Mr. Olympia time, he was talking about, he's like, yeah, all these other guys, they can eat, just pounds of steak and pounds of beef and steak and eggs. He's like, yeah, I can't do that. So I've got to split it up. I've got to eat, like a 10-ounce steak here and a 10-ounce steak here, and then go to work and do this. But it was all steak and eggs, steak and eggs, steak and eggs, steak and eggs. And, and then we sort of got away from that. People started just going crazy on the carbs and just not understanding, biochemistry. And I don't blame, bodybuilders for not taking college level biochemistry. But if you did take college level biochemistry, you'd understand that that's not what you want to do.
Okay. Well, we're coming almost to the end now. I've got one last question for you. And that question is, like, since you've become carnivore, have any of your thoughts changed about the diet? Is there any cautions that you would give people that are considering getting on the carnivore diet?
Not necessarily cautions. I mean, I do always recommend that people, educate themselves, really understand, what they're doing and why, understand how to do it successfully. There are a lot of different opinions on how you do it and what the best way to do it is. And so, just try to just keep it simple and just eat fatty meat until it stops tasting good. Only drink water, cut everything else out, and, salt to taste. Sometimes you can lose a bit too much, salt and electrolytes as your insulin is normalizing. And if that's the case, you're getting sort of dizzy when you stand up or feeling a bit off, add in a bit more salt, see how you feel. So I think the one thing that I've sort of changed on is not really changed. It's sort of been consistent, but I don't think that you have to have a bunch of organs and all these other sorts of things, or certainly don't need to take supplements unless you have malabsorption issues, unless you're not able to get enough nutrients normally. If you have an MTHFR gene mutation, 44% of women have MTHFR. You might need a bit more folate and B12, and so you might have to include a bit of liver. I still think that most people don't need that. But if you want to be even more optimal, some people do better with a bit of that. And also, when it's early on in your adaptation, almost everybody's low in these nutrients. And the more people I check their bloods when they're coming into me in my medical practice, everybody's nutritionally deficient. Everybody has B12 deficiency and vitamin D deficiency, zinc, magnesium, everything. I mean, people are just low on everything pretty much. And so, while you can catch up, it can take a while just eating meat, even though it's very nutrient dense. And I do see these people's, nutrients go up. Sometimes it can be beneficial to add in a bit of organs early on to catch yourself up early. And it may not be that you need to perpetuate that. I mean, I barely ever eat organs. And my nutrient levels are fantastic, but I've been doing this for years. And so I'm able to maintain that. And I was able to build up over time. And I don't know what mine were at the beginning because I didn't test my bloods. I didn't test my bloods for a couple of years after I got back into this, and they were all great. And so, but the people I see, they're not great, especially when they're eating sort of a more plant-based diet or processed food diet, which is a plant-based diet. And so I think organs go a long way. It's nature's supplement, and it's nature's multivitamin. And so that can help get you where you want to go faster and without having to take, synthetic supplements and things like that. And so that's one thing that I've sort of, not changed on, but sort of, I haven't changed my opinion on that. I still believe the same thing, but I do think that I do see the utility in adding in, utilizing some organs, especially early on, to get you up to, better nutrient levels quicker.
Mm-hmm. Okay. All right. Well, Dr. Chaffee, is there anything else that you would want to say to the audience? Anything that you'd want to kind of um, clarify or explain more before we say adieu?
Well, I think the main thing is just to try to hopefully let people sort of think about this a bit more and understand that meat really isn't the horrible evil monster that we've been led to believe that it is. It's not the cause of all diseases and illnesses. It absolutely is not. It does not cause diabetes, does not cause cancer, does not cause heart disease or any other health issue. It doesn't cause any health issues. It is extremely important and it's extremely necessary for us to eat meat. Even if you don't want to do carnivore, it is important to get these nutrients. They don't exist anywhere else. And so it's very important to get these nutrients from meat. And so I just, my main thing is I want people to eat whatever the hell they want, but I don't want them to be eating a certain way because they think that, that's really healthy for them. Eating a plant-based diet because they're being told a plant-based diet is good for them. If you want to eat a plant-based diet, fine. But, don't do it because you think meat is going to hurt you, because it's not. Doctors used to tell people that cigarettes were good for you. I swear to God, in the 1950s, I've read this, the people in the Tour de France, the cyclists in the Tour de France, would smoke cigarettes in the morning because they thought it was good for their lungs and their cardiovascular system, because that's what they were told. And they're told, alcohol is very good for you and all this sort of stuff. And so they were just boozing all night, smoking cigarettes all day, and doing the Tour de France, which was the same distance, but it was on dirt roads and single geared bikes. I mean, these guys were badasses and, absolute troopers. And they're smoking like chimneys, right? Because they were told by doctors and sports scientists that smoking was good for them, right? Their trainers are saying, yeah, you got to smoke. That's what's going to get your heart rate going and open up your lungs. Like, good Lord. So, I don't want that to happen now. These, I'm going to go plant-based and, game changer, all that sort of stuff. Yeah, well, a lot of people game changer themselves into retirement, like Cam Newton. He went, that changed his game for sure. He was, league MVP multiple years, Super Bowl MVP, and then he went plant-based. His performance dropped to hell. He started getting injuries he couldn't recover from, and he ended up going on injured reserve. He tried to come back. He ended up destroying his performance. He ends up getting cut, and he's never been the same, and he never played to the same level ever again. And that's what that does, because he believed the propaganda that meat was evil, meat was harmful, and it caused disease, and you'd be a better athlete if you ate a bunch of broccoli. Well, I'm sorry, it's just not true. And he destroyed his career doing that, and many other people have as well. Have had these injuries that just don't heal properly, and they don't do well. And so, there's always exceptions. There's always people that, do a plant-based diet and can do well. But the majority of people that do a plant-based diet destroy their athletic career and their health. And so, those outliers in the other direction are the exceptions. They are not the rule. And so, don't avoid meat just because you're told that it's bad for you, because it's not. Don't eat a bunch of plants because there's some sort of superfood. That's a marketing ploy. That's someone trying to sell you kale. Kale sucks. Kale was propagated by a lady who owned a marketing company in New York, because she just wanted people to eat this way. And so she started, paying Beyonce to wear a kale sweatshirt and getting people to talk about kale and, have kale dishes in, New York, upscale restaurants and things like that. She was paying them to do that. And then all of a sudden, kale smoothies, kale this, kale that. Kale gives goiters to sheep and kills their babies. Kale gives goiters to the people who drink the milk from cows who eat kale. Kale is toxic, and don't eat it. This is unless you want to, unless you want a goiter and you want to destroy your hormones and eat something that tastes like garbage. Fine, eat it then, but don't eat it because you think it's good for you, because it's not.
Nice one. Thank you, Dr. Anthony. I'm so glad we managed to do this. There's been a lot of back and forth, trying to make it happen. And yeah, I thank you for your patience and also for your time today, having just finished work as well. So
Yeah.
thank you. Thank you.
You're very welcome. It was a pleasure. I'm glad we got to finally get time to do this.